Okay, we're heading into our last week here in Precalculus. We have 3 sections to cover. The first homework will be section 5.3 and 5.5. So we'll go over section 5.3 here first. And again, learning objectives, but basically we're going to use the double angle, power reducing, and half angle formulas. And these are the examples we'll go over. So what I mean by double angle formulas is the sine of 2 theta, cosine of 2 theta, tangent of 2 theta. These actually are easily derived from the sine of alpha plus beta, where both alpha and beta are theta. So in other words, sine of theta plus theta would be sine theta cosine theta plus cosine theta sine theta. So in other words, it's 2 sine theta cosine theta. Cosine of theta plus theta, or cosine of 2 theta, would be cosine theta minus sine theta sine theta. So in other words, it's cosine squared theta minus sine squared theta, which we can then use the Pythagorean identity of cosine squared theta plus sine squared theta equals 1. So cosine squared theta could be 1 minus sine squared. That gives us 1 minus 2 sine squared theta. And sine squared theta would be 1 minus cosine squared theta. So that would give us 2 cosine squared theta minus 1. So those are 3 different identities you can use for cosine of 2 theta. Tangent of theta plus theta, tangent of 2 theta, comes from tangent of alpha plus beta. Right? So in other words, it's 2 times the tangent of theta, and then 1 divided by 1 minus tangent squared of theta. The power reducing formulas, or if we want to reduce the power from 2 to 1, so in other words, we want sine squared. We don't want to work with sine squared theta. We'd like to work with cosines or sines in terms of just 1 power. So sine squared of theta is the same thing as 1 minus cosine 2 theta divided by 2. If you play around with the cosine of 2 theta from up here, you can see how that works out. Same with the cosine of squared theta, that's 1 plus cosine 2 theta over 2. Again, if you work with cosine of 2 theta and then work with this guy, you get that this is the identity for cosine squared theta. And tangent squared of theta, you can think of that as sine squared theta over cosine squared theta, and that's where this comes from. 1 minus cosine 2 theta over 1 minus plus cosine 2 theta. The half angle identities, if you want the half angle, so sine of theta over 2, you can think of taking the square root of this guy, and that's how you get plus or minus 1 minus cosine of alpha over 2, alpha over 2. Cosine of alpha over 2, take the square root of this guy where theta is alpha over 2, so you get plus or minus 1 plus cosine of alpha divided by 2. And the tangent of alpha over 2 is take the square root of this guy, so where theta is alpha over 2, so you get plus or minus the square root of 1 minus cosine alpha over 1 plus cosine alpha. And the plus or minus sign for these guys has to be determined based on where you know theta over 2 is, which quadrant theta over 2 is in. Okay? All right, so for example 1, you're given that the tangent of theta is 4, and you're told that theta is in quadrant 3. So the first thing you want to do is draw yourself your reference triangle. And we know we're in quadrant 3, so that would be negative y-axis, negative x-axis. So you get negative 4 over negative 1 to get the tangent of theta, right? Opposite over adjacent. Use the Pythagorean theorem, you can see that hypotenuse is the square root of 17. So theta is this guy. So if you want tangent of 2 theta, sine of 2 theta, then we use our double angle identity. So that's 2 times the sine of theta times the cosine of theta. So looking here, the sine of theta is minus 4 over square root of 17. Cosine of theta is minus 1 over the square root of 17. So you simplify that and you get 8 over 17. And then if I'm wanting to know what the cosine of 2 theta is, it's cosine squared theta minus sine squared theta. So again, cosine of theta is minus 1 over square root of 17. I square that. Minus sine squared theta, so sine of theta is minus 4 over square root of 17, square that. So you get 1/17 minus 16/17 or minus 15/17. And the tangent of 2 theta is 2 tangent of theta divided by 1 minus tangent squared of theta. So that's 2 times 4 over 1 minus 4 squared, or minus 8/15. Example 2. If we want to find the exact value of 1 minus 2 sine squared of theta, in this case theta is pi over 8, we know that that's equal to the cosine of 2 theta, right? If you go up here, cosine of 2 theta is 1 minus 2 sine squared of theta. So I notice down in example 2, I have 1 minus 2 sine squared of theta. So that's equal to the cosine of 2 theta, which is the cosine of pi over 4, and that's one we should easily know is 1 over root 2, or root 2 over 2. Third example, we want to use a half angle formula to find the exact value of the tangent of 5 pi over 12. So that means 5 pi over 12 is the same thing as half of 5 pi over 6, right? Multiply that, you get 5 pi over 12. So alpha is 5 pi over 6. So I want the tangent of alpha over 2, where alpha is 5 pi over 6. So because 5 pi over 12, I need to understand where alpha over 2 is, right? Alpha over 2 is. Alpha over 2 is 5 pi over 12. Right? So where's 5 pi over 12? 5 pi over 12 is over in this first quadrant, so the tangent will be positive. That makes sense? So I need to use the positive sign here. And then I say, okay, this is alpha, 5 pi over 6, right? Alpha over 2. So it's plus the square root of 1 minus cosine of alpha over 1 plus cosine of alpha. So I need to be able to evaluate cosine of 5 pi over 6. So 5 pi over 6 right here, these my reference angle of pi over 6 are 30 degrees. So label the three sides of a 30, 60, 90 as 1 minus root 3, 2, right? Side opposite 30 is 1, side opposite 60 is root 3, but I need to label it as minus root 3 because it's on the negative x-axis. Hypotenuse is 2. So the cosine of 5 pi over 6 is negative root 3 over 2. So this is 1 minus cosine of 5 pi over 6, which is 1 plus root 3 over 2, divided by 1 plus cosine of 5 pi over 6, which is 1 minus root 3 over 2. So this is 1 plus root 3 over 2. This is 1 minus root, the numerator here, if I multiply it into one fraction, it's 2 plus root 3 divided by 2. And the denominator is 2 minus root 3 all divided by 2. So the divided by 2's would cancel, and I get 2 plus root 3 over 2 minus root 3. And then the whole thing is under the square root, because this is what we had originally. Okay, example 4. We're told that the cosecant of alpha is minus 25 over 24. Cosecant, remember, is 1 over the sine of alpha, so the sine of alpha would be minus 24 over 25. And your total alpha is in quadrant 4, so alpha would be over here, which in other words, it's all the way this guy. Okay. So if alpha is in quadrant 4, that means alpha over 2 is in quadrant 2, right? If I'm over here, then half of that would be over here. All right, so I can get that the sine of alpha is minus 24 over 25. So this is my reference angle. Alpha starts from positive x and goes all the way around, but my reference angle is this guy. So the opposite of that is minus 24 over 25. And then that leaves me using the Pythagorean theorem that this side is 7. Okay, so I know the cosecant of alpha, which told me the sine of alpha, allowed me to figure out this reference triangle. And then I know alpha over 2 is in quadrant 2. So what's the sine of alpha over 2? Well, I need to take the positive square root, because sine is positive in the second quadrant up here, of 1 minus cosine of alpha divided by 2. So cosine of alpha would be 7/25. So 1 minus 7 over 25 divided by 2. 18/25 divided by 2 is 18/50, or 9/25, right? Either way, you simplify that, you get 3 root 2 over 5 root 2. The root 2's could cancel, you get 3 over 5. And then the cosine of alpha over 2, well, in the second quadrant, cosine is negative up here. So I have to take the negative square root of 1 plus cosine of alpha over 2. So the negative square root, you work that out, you get negative 4/5. And the tangent of alpha over 2 in the second quadrant, tangent is negative, so I did negative square root of 1 minus cosine of alpha over 1 plus cosine of alpha. Work that out and you get negative 3/4.